Morning, everyone. So we've had a lot of great talks for the last day about APIs, API technology, business strategies, and this talk's going to be a little bit different. So I work for a 3D printing company called Shapeways, and we're really focused on digital manufacturing and production. And one of the things that we've really seen over the last, I'd say like 5 or 6 years, is that APIs are starting to make their way into manufacturing. And they're starting to unlock different potentials and capabilities that we haven't had before. So what I wanted to do today, instead of talk about really bleeding edge API stuff, was actually to focus a little bit more on what may seem a little bit mundane to the attendees of this conference, but to give you a really good case study of how things are progressing forward in the API space, or in another space driven by APIs. So a really quick introduction about me. I'm the VP of Architecture at Shapeways. What that means basically is I figure out how to make everything work together. So taking our printers, taking our other manufacturing technologies, our website, uploads, 3D processing, all these different pieces, making sure they interoperate together and that they scale well across our business. And Shapeways, we're a 3D printing company first, but our real goal is to enable people to create products at scale. But that's enough about that. But to understand a little bit about where we are today, I think it's helpful to talk a little bit about the past. So when we think about the Industrial Revolution, we generally use that definite article, the, as if it was a thing that happened one time and represented all of the quantum leaps that we've made since then to get us to where we are today. And that's actually not really true. We've had 3 distinct industrial revolutions, at least by most people's count. The first one being mechanization, capture of steam power, doing things like actually uniting machine and man to create different products together. The second industrial revolution is the advent of mass manufacturing. You think of Henry Ford, the Model T, different ways of making things on an assembly line. And the third industrial revolution is the semiconductor revolution. It's computers, starting with mainframe machines, ENIACs, going down to personal computers, to all the phones and tablets that you have today. Now, a person much smarter than me, Klaus Schwab, as the leader of the World Economic Forum, believes that we're on the cusp of a 4th industrial revolution. And that 4th industrial revolution, by his read, is that it's the integration of what they call the cyber and physical systems. What that really means is what we think of as Internet of Things, smart devices, connecting manufacturing technologies with digital technologies and seeing sort of what comes of that. And these industrial revolutions all have a few things in common. They're all drivers of cultural change. It's hard to imagine your life without the smartphone in your pocket, but 20 years ago that wouldn't even be the thing you consider. When you look at the first industrial revolution, that brought people into urban centers, creation of the factory and making sort of city life into what it is today for its ups and downs. The second industrial revolution enabled people to travel further distances, creating cars, no longer relying on horses or carriages or walking. So when you're able to do that, then you create sort of the suburban or at least the sprawl environment, the ability for people to travel to places like Austin from New York, which is where I'm from. And then the third industrial revolution is the semiconductors and basically gives us all the jobs that we have today. But each of those revolutions was characterized by the advancement of my computer going to sleep. Marvelous. By the advancement of one particular technology. The first industrial revolution was steam, the second industrial revolution was petrochemicals like gas, oil, kerosene, and the third was semiconductors. And each subsequent revolution has been built on the one prior. So I think that's enough of a history lesson for the moment. What I'd like to do is talk a little bit about the state of the industry for manufacturing. So after these 3 industrial revolutions, where we are today is we have manufacturing centers that look a lot like this. This is a shop floor in Boeing out in Seattle. They have a couple things in common. They're big operations. You're thinking aircraft hangars, production floors, factories, huge spaces that are sitting out there and building large stuff. You've got specialized machines and hardware. The machine that they use to test the wing of the Boeing 787 is not the same machine that they use to test the wing of one of the Airbus jets. You have very, very specialized components for making these things. And a good example of this is in the automotive industry right now. When you look at what companies like Volvo and companies like Toyota are doing, they're actually taking their production lines and they're trying to put the same base platform of an engine and a transmission and a car frame and suspension into multiple different vehicles. They're not doing this just because that's, simplifies their backlog in parts. It's actually to get some modularity and reuse out of their equipment as the factories, as trends sort of change. These machines do tend to have software control, these SCADA systems. What these are is they're purpose-built systems that leverage, what we think of as sort of older, more embedded technology, things like programmable logic controllers, program with ladder logic to actually do control systems. And if you've ever been to one of the many microbreweries they have in Austin, you'll see one of these big panels with all the different pieces of information about what's flowing through the system. That's a SCADA system. And this industry has gotten us to where we are today, which is really far. But there are some limitations. Biggest limitation is the requirement of constant human presence with these machines. Despite the fact that we have automation on all these assembly lines, we still need on or near-site human presence to do controls and monitoring and all of the different aspects to keep things safe and functional. We do have automation in this environment, but the automation that we have is incredibly specialized. This going back to, you see all these assembly lines with Tesla and the robots and putting things together, and that's all really exciting. But again, that assembly line can't make anything besides that car. And if you wanted to adjust those pieces of robotics to do that, you could. But again, it would be sort of like things. You can make another car, maybe a different car with some significant tuning and investment, but you couldn't make, say, a refrigerator. And the third thing, and maybe the most germane for this audience, is that these are all closed systems. So there's control, there's monitoring, there's reporting, all kinds of great information if you buy that company's product or if you work directly with that company to have them develop something for you. And that makes it really difficult to integrate different parts and different components into these manufacturing processes and cycles. So what we end up with is one company who's a contract manufacturer basically owning the entire production line of all of these different places, which is difficult for flexibility. Now I want to talk a little bit about the rise of digital manufacturing, which is what I do. So digital manufacturing, 3D printing is an example of, but the way digital manufacturing is traditionally defined is by being computer-aided from the start to the end. The product is made in computer simulations, AutoCAD, SolidWorks, pick your engineering tool of choice. It's tested, it's simulated, it's run through heat tests, stress and strain, all of that stuff in the digital world. And then that digital file is provided to the manufacturing line, and that file is produced from there. So these tend to focus on process over the product itself. Rather than worrying specifically about what they're building, what you're trying to get is a machine that's capable of building a class of things. So a great example is a 3D printer. You think about MakerBots that you've seen, all the different stuff people are running off of it. The same printer that makes a replacement part for a baby stroller is capable of making a lapel clip for this microphone or a case for this remote control. So having that sort of flexibility inside of a manufacturing process allows you to take a more modular and composable approach, something a little bit akin to microservices. And there's, these things are not the same industry, but they do rhyme. So there's a lot of different overlaps between software development and modern manufacturing. So what we do is we take, instead of having these single-purpose machines or single-function machines, and we actually combine and compose them together. A good example would be this ring I'm wearing, my wedding ring. It's 3D printed. We do that in metal. This is made in sterling silver. We take it in sterling silver, then we polish it, then we antique it using liver of sulfur, and then we actually perform one final gloss coating and ship it out. So it's a number of different sort of fusion of traditional and new manufacturing processes. And that's a complete sort of mental shift that you can make from where we started with these sort of large factories making airplanes to these smaller factories. This isn't our factory, but it looks a lot like it, where you have these machines that do different purposes and are making hundreds of different products at the same time. And that's what's really exciting about this. But limitations do still apply. Traditionally in this space, and digital manufacturing isn't new, it's been around since the 80s, stereolithography. There are still platform limitations that apply. Actually, you have these traditional original equipment manufacturers who are making the same pieces of technology that they've made in the previous mindsets. They're still applying the previous business model. You have proprietary systems, you have closed platforms, you have no APIs, until now. So in the last few, I would say, maybe like I said, 3 or 4 years, that's probably a fair estimate. These manufacturers are starting to get what's going on in the digital space, in the software space, more so than they had in the past. They're seeing the rise of these different manufacturing services that people can leverage. They're realizing that companies like mine have a bunch of different printers and a bunch of different manufacturing technologies that they're trying to link together. And they honestly have people like me bothering them all the time. So as we get this sort of diverse set of different 3D printing manufacturers, and I'm not talking just 3D printers on the sort of desktop MakerBot scale. But real production pieces, things the size of a refrigerator or larger, we have dozens of these things in our different sites across the world. And they all have different capabilities and things that they can accomplish, and they're all made by different manufacturers. So as we got a more and more diverse manufacturer lineup, we realized that other people who were in the same space as us were having a similar issue, where we had no way of connecting these individual pieces together. So we went to the manufacturers, we started to talk to them about some of the things that we needed, and they realized pretty quickly that giving us the opportunity to connect to their platforms in an open way and talk to them was actually going to be much more of a benefit than a risk from a business perspective for them. So what they started doing is providing us with APIs to talk to these pieces of equipment. Now these things are basically, in fact, I'd say half of them are actually just the same physical server boards we run in our data center inside of a printer. So they have full networking stacks, they're running Linux, they're doing all the things that you need to do to actually have one of these successful pieces of API software running on it. So what they did is they just put it down. It wasn't that hard for them to do. Just build a piece of connectivity, run a small web server, and talk to the printer. And what they started doing for us first was what we call monitoring and reporting. So what they would do is tell us both real-time and historical status of what our 3D printers have done, which may not seem like some kind of earth-shattering connectivity, but for us it really made a huge difference because it gave us the opportunity to understand a little bit better what our machines are doing. I'll talk about that on the next slide. But I think the real takeaway here is that open standards, these are all mostly, I'd say 95% of them are REST APIs. There's a couple people who actually were ahead of the game on the API space, but kind of stopped, so we're using SOAP still, that's fine. These open standards are powering our ability to plug these different pieces of printing technology into our overall business. So we can understand how much we're selling, how much we're making, what contribution each of these machines has to our bottom line and top line, and whether or not different manufacturing processes that we're running on these printers are actually effective for our business or not. So I had mentioned before that monitoring and reporting APIs were sort of where we started. And this is the easiest thing to do, right? This is just taking basically a database that they have, whether it's log files, some kind of disk store, or in some cases actually IBM DB2, and just reporting out on the API what's happened in the past and what's going on right now. So some of the products this has enabled us to create, the first one you see here on the screen are Slack and SMS notifications when something happens with the machine. When the machine finishes a job, when something goes wrong with the production process, or when some other action needs to be taken by the user, say to validate that a test piece came out properly, we can just emit a message into one of our Slack channels. And this is something that has made a huge difference for our production staff because rather than having to walk down to the shop floor from the office space and sort of examine every machine and make sure that things are working properly, I kind of equate it to animal husbandry. What we can do instead is have them sit at their desk performing other tasks, things that humans are good at, and letting the computer actually take care of the sort of monotonous task of going back and forth and figuring out what's going on with the machine. So that's helpful for real time. It's also helpful for our metrics and report generation. One of the guys I work with always likes to say that graphs are really great things for management and no one actually cares about them, but I disagree. But I work in management, so that could be a biased opinion. But what we're able to do is actually get full-fledged metrics on how this machine has performed over the last week, month, year. That we can actually do anomaly detection on that data. Are things running hot in this particular area of the build? Are we seeing when we put stuff in the corner here that we have a 10% higher defect rate that we're having somewhere else in the machine? These are all things that we've actually uncovered since building this about 6 months ago. So it's given us much more insight, turned the black box clear in the software world as to what's going on with our actual production hardware. And the third thing that enables us to do is capacity and growth planning. It helps us understand what our optimal throughput is for the machines, how much we can actually get through them at our peak moments, and understand whether or not we need to invest in new hardware. And this isn't just like buying another data center. These things cost $500,000 and up. So it's a real capital expenditure that we have to plan for, and our finance teams would prefer that we say, hey, actually, yeah, we really need this, and here's why, versus I would like $5 million, please, to go buy some 3D printers, which they kind of roll their eyes at. The next sort of evolution of APIs that we're seeing beyond the monitoring and reporting is what we're calling command and control. And this harkens back to sort of the full features of the traditional manufacturing space, where you're able to actually have some remote control to initialize, to plan, prepare, start jobs on different pieces of technology. And this is really big for us. Obviously, this enables remote operation. That same person who is sitting up in the office off the shop floor can initialize a print job completely digitally, taking advantage of a digital supply chain. When an order comes in from us, our order comes in as a 3D model file, anywhere from 5 to 100 megabytes. That model file can just be passed around really cheap when compared to shipping around actual physical parts and raw materials. So we can say, person sitting at the desk receives the order comes in, they check it, make sure they can print it, they can just send it right to the printer without ever leaving their desk and have the production start. And that's interesting in that sort of near-term case. But where it gets more interesting is when you start to think about it in a global scale. So we are a global company. We have offices in the Netherlands, we have offices in the US, both East and West Coast. And we also have different contract manufacturing partners all over the globe. So someone in India can receive an order at, let's say, noon, Mumbai time, check the part, make sure everything's working properly, and realize that that order is actually going to be shipped to New York City. So what they can do, leveraging these APIs, is rather than start the print job in India, produce the physical part, have to deal with customs, logistics, and shipping, and all these lead times that come along with it, and costs, they can just send this part to the printer in New York City and click a button and start printing. And that's really powerful for us, because what it means is that we can now run a 24/7 operation in all of our different facilities without having to have someone actually physically present. So, running 3-shift, is tough for everyone. It's tough for the people who work there. It's tough to find people who want to do it. And these machines, honestly, for the most of what they're doing, they don't need actual attention. So having someone there just to sort of monitor them seems like a waste of time, both for the person and for the company. So being able to sort of initialize these jobs globally has allowed us to optimize our workforce, allowed us to let people sleep, is really what it comes down to, instead of running shifts where people have to, for a week, a month, have to be working the overnight shift. This lets people rest, lets people feel a little bit better about the work that they're doing, and it makes sure that we're still leveraging our machines in an optimal way. And I kind of clued into this a little bit before. When I'm talking about distributed manufacturing, what this truly means is that if a part gets ordered somewhere, we can actually produce that part as close as we possibly can. We have the opportunity now to do that regardless of what time in the morning it is, what the lead time is for the production part, and who's ordering it. If we need something to be ordered, if we need something to be delivered to Australia, we don't have a facility in Australia. But we do have one in India, and we do have other production partners in Indonesia. Traditionally, what we would do today is manufacture the part in the US and then ship it to Australia and wait 5 days or whatever it takes to get over there. Hope it gets through customs. Now, if we're able to actually be just one shipping day apart, we have a completely different opportunity that we can solve, that we can sell to our customers. Now, this is just the beginning of what we're trying to do here. So we're at the infancy, I think, of these APIs and understanding what's actually possible for them. So right now, because of conferences like this one, organizations like Nordic APIs, getting the word out and educating people on what APIs are actually capable of and what common practices are, there are standards that exist in the world, whether they're REST, whether they're SOAP, whether they're GraphQL. People are leveraging these standards, which is good. I would say their APIs are, for companies that aren't software-first companies, their APIs are pretty easy to understand, pretty easy to use, and pretty well implemented. But there's no standards board around the actual industry itself to understand what matters about a machine. How do you define a configuration? How do you define what a print job or a production job is? How do you identify what parts exist as a part of the job and what those entity relationships are? Without that sort of standardization, it's actually takes a little bit of time to spin up these new APIs when someone puts one out. But if a standards board were there to say, hey, this is how you describe a printer, this is how you describe a job, it would be easy to hand that specification to these companies, have them implement it, and then just tie directly in. And I'm probably preaching to the choir on that one, but this is a conversation I have with the vendors every time I talk about it. Next thing for us would be to actually get more of these original equipment manufacturers on board. We've done a pretty good job in the past of getting people spun up and running, but it's always taken some convincing. Hi, hardware company, please invest in some, not necessarily cheap software development so that we can better use your products. They're going to come to us with, well, how is that going to work? What benefit does that have for us? Why is that not just helping you? So figuring out how to sell that business case to customers or to vendors is something that we've done, and now we just have to spend more time with the rest of the folks in the industry doing that sort of diligence to get them on board. And this is really only the tip of the iceberg. As this technology continues to develop and we have more abilities to interoperate with our machines, you can imagine a world where we would start a print job here, and then by the time it got up here, we could actually stream in new physical parts to the printer as it was going. Because as we build like that, then you really are able to optimize for your build density and for your delivery time to your customers. And that's it.